Following my previous video on ApoE genotype and Alzheimer's disease, in this video I'd like to make a few deep dive notes about the glymphatic system. Glymphatic system is the one that clears the brain waste by moving the CSF, cerebrospinal fluid, along the perivascular spaces into the brain tissue, then flushing it between the brain cells, so through the intercellular space where it mixes with interstitial fluid, and then out through venous and lymphatic routes. And during this intercellular flushing process, it removes different waste molecules, including beta-amyloid and tau protein, which are involved in Alzheimer's pathogenesis. And obviously, if we know that there is a system that flushes away the substances that eventually lead to Alzheimer's, we would definitely like to figure out what makes the system work better or worse. And here we need to look at three main contributors. Norepinephrine tone, which is most notably different in the states of arousal and deep sleep. Sleeping position, which directly affects intracranial pressure. And glycemic effects, including both systemic and CSF glucose levels. Let's look at norepinephrine effects first. High norepinephrine levels, such as characteristic in arousal states, cause the astrocyte cells, which are the glial cells around the neurons, to contract their feet. And this brings neurons closer together, and thus the interneuronal spaces between them become tighter and glymphatic flow through this space is reduced. So high norepinephrine, tighter neurons, reduced flow. On the contrary, during deep sleep or in the states of meditation where norepinephrine levels reduce, interneuronal spaces widen and glymphatic flow through them is enhanced. From that we can conclude that practicing meditation, but even more so getting sufficient amounts of deep sleep, is imperative for adequate glymphatic clearance. Next, let's look at the effects of different sleeping positions that have also been found to affect lymphatic clearance, and they do so mainly via their effects on intracranial pressure. When intracranial pressure, which is the pressure inside our skull, is elevated, it's more difficult to push CSF through the spaces between the neurons, and thus glymphatic clearance reduces. So the higher the ICP, the lower the glymphatic clearance intensity. So sleeping and other bodily positions that increase intracranial pressure are likely going to decrease the glymphatic flow. And the current view is that sleeping on your side or with 10 to 30 degree head end elevation, which slightly reduces ICP, will improve glymphatic flow and clearance. Interestingly, the view that was popular not so long ago, that having leg end elevation with a slight head down position would improve glymphatic clearance, is now not considered to be true, because this position significantly increases intracranial pressure and thus reduces glymphatic flow and clearance. And what probably will strike many of you, the current view is that sleeping in the prone position, so sleeping face down on your belly, results in the highest ICP and the worst glymphatic clearance. Sleeping on the back is somewhat in between, and it's related to intermediate ICP levels and moderate glymphatic clearance. So if we are aiming optimal glymphatic clearance, we should ideally avoid sleeping face down, avoid sleeping head down, and somewhat on the back, while giving preference to sleeping on the side or maybe with a 10 to 30 degree head end elevation. I must add that the conclusions about sleeping positions and glymphatic clearance are largely derived from animal studies and also from mechanistic principles that link the interplay between ICP and glymphatic flow. Mechanistically, all this appears really plausible and seems to offer very practical, simple take-homes. And as last but not least, let's look at the relationships between carbohydrate intake, blood glucose levels, and CSF glucose levels and glymphatic clearance. The studies show that spiking glucose within 1 to 2 hours of sleep onset may disturb sleep architecture, particularly delay entry in slow wave or deep sleep, which is the same. They may also acutely elevate cortisol and increase sympathetic drive with increased norepinephrine levels. And as a result, all this will lead to impaired overnight glymphatic clearance. Studies have also demonstrated that chronic hyperglycemia and high glucose in the CSF are disruptive to glymphatic clearance. And I would like to highlight two practical take-homes here. One for the people with diagnosed diabetes and another which is more generally applicable. Diabetes increases the risk of Alzheimer's disease and dementia as such, which is both linked with and further exacerbated by the fact that diabetes impedes glymphatic clearance. So if you are diabetic, aiming excellent glycemic control during the nighttime is of paramount importance. But in broader perspective, we should all be ideally aiming concluding our last meal of the day about 3 hours before bedtime so that we can exclude these glucose spikes close to the sleep onset time. On this note, I'd like to add that I advise all my clients and everyone else seriously interested in optimal metabolic health, performance, and longevity to, at least in the short term, try and wear the CGM and get the insights and how your body responds to different foods, how it regulates glucose levels, and how you should optimally plan your meal timing and composition to get the best glycemic control, including during the night and during the deep sleep when the glymphatic system is most active. The principles of maximizing glymphatic clearance we've discussed in this video are probably most important for the people at the increased risk of developing dementia and Alzheimer's disease. For example, for those of us who have ApoE4 genotype or type 2 diabetes or obesity. But generally, all of us who are aiming optimal performance not only when we are 20 or 30, but further down the line into the senior age, we will all find these principles beneficial. If you haven't already done so, feel free to check my previous video where we discuss genetic predisposition to Alzheimer's disease and all the actionable tools for dementia risk reduction.